Perpendicular lines.
Perfect. Okay, like Scott said, we're going over parallel and perpendicular lines. And here's our slope y-intercept form. And we're going to compare our parallel and perpendicular lines in slope y-intercept form. The reason being is it'll be easiest to tell if something is parallel or perpendicular. So, parallel lines are when the m's in the two equations, so we'll call it m1 and m2, are equal to each other. No other part has to be equal. So what we mean by that is, say I have y is equal to 3, x plus 3, okay? And then y equals 3x minus 2. These are known as what type of line? Anyone know? That's right, these would be parallel. And the reason they're parallel is because their slopes are the same. So if the slopes are the same, what that means is they will never cross each other as long as you draw them. As far as you go, they will never cross each other. Okay? And we usually use this symbol to represent parallel lines. So these two lines are parallel, and we'll prove it using our Desmos here. We'll type in those two equations. 3x plus 3, we said? Okay, so if you notice, this has a slope of 3 over 1 and a y-intercept of 3. And our other one, we had 3x subtract 2. Okay? These two lines, our y-intercept was negative 2. As far as we zoom out, will never, ever cross each other. The farther we get, the more they look like they're overlapping, but they'll actually never cross each other. Okay? So they'll continue forever parallel, because these slopes are the exact same on the two lines. Okay, so that would be the slope y-intercept form, but let's say we want to transfer it to standard form and we want to know if our lines are parallel. So we're going to put these into standard form, and in order to do that, we have to set them equal to 0. So I'm going to build two new equations. This was our example 1. Okay, here's our example 2. And we're going to discover these. So let's say I have y is equal to 2 over 3x minus 2, and y is equal to 2 over 3x plus 4. Are these parallel lines? Yeah, their slopes are the same. So let's see how we can look at it. From looking at this, we know they're parallel. Let's turn them to standard form. So to change it to standard form, I want to kind of get rid of any of our fractions, right? Actually, first we won't do that. First we'll move our y over. So we move our y over, this becomes 0 is equal to 2 over 3x. That's not an x. 2 over 3x. When we bring our y over, what does it become?
Negative.
Negative. So negative y minus 2. And in this one, we have 0 is equal to 2 over 3x. Again, we move our y over, so negative y plus 4. Now remember, in our standard form, we don't want any fractions. So how do we get rid of this denominator here?
Multiply them.
What do we got to multiply by? By 3, right? We'll multiply both. So this means every term we multiply by 3. So when we multiply this by 3, what happens? Our 3's cancel out, and we're left with 0 equals 2x. What is negative y times 3? That's right. Negative 3y. And what is negative 2 times 3? That's right. Negative 6. Okay. And our other version is the same idea. We multiply this by 3, and by 3. And we get, the 3's cancel out, 2x. We get 2x, those 3's cancel out, minus 3y plus 12. Now what's important here is to tell if something in standard form has the same slope or are parallel. What we need is we need the coefficients in front of the x to be the same and the coefficient in front of the y to be the same. Okay? Both of these must be the same, and if so, that means they are parallel lines. If they're not the same, then we do not have parallel lines. Okay? When we've set it equal to 0. Any questions about that? Okay, perpendicular. Perpendicular lines are a little different. Y equals mx plus b. And in this one, we get our m is a negative reciprocal. I think that's spelled right. A negative reciprocal. in order to be perpendicular. Now, what that looks like, if I have y is equal to 2x plus 3, let's say. Again, the only thing that's important for these are our slopes. So I look at the value of 2. Well, I'm going to change it into a fraction. 2 as a fraction is written as what? 2 over 1. Okay. The negative reciprocal. So I need to multiply this by negative 1. And when I do that, what does it become? It just becomes negative 2. But I also have to make it the reciprocal. And the reciprocal is when I flip the fraction. So in order to be perpendicular, we end up with negative, because we multiplied it by negative 1, 1 over 2. Okay? So in order to be perpendicular, this is y is equal to negative 1 over 2x. And our intercept can be anything we want, say negative 6. So let's actually check that these are perpendicular. And to be perpendicular, I guess we should talk about it. That means these lines cross each other, and where they cross, the angles are 90 degrees. Okay? They create 90-degree angles where they're intersecting each other. So, the values we used were the value of 2, and then we said we had a negative reciprocal of negative 1 over 2. And if you'll notice, though we can't technically prove it here, well, I can if we use this, but we don't do that in this class. These are crossing at what pretty much looks like 90-degree angles. So our slopes, which were 2, and negative 1 over 2, are negative reciprocals of each other. The y-intercepts are not as important. Okay? So that's in our slope y-intercept form. All we have to make sure is that the slopes of the two values are negative reciprocals of each other. Okay? Now, standard form is a little different. For standard form, let's take these two equations and put them in standard form. Y equals 2x plus 3. Y equals negative 1 over 2x minus 6. To make it standard form, we've got to set it equal to 0. So we bring y over. 0 is equal to 2x. What does y become? Very quick. Negative y. And when we bring y over in the other one, what does it become? Negative what? Good. In standard form, what do we have to make sure there are no what? Fractions. Okay? We've got to make sure there are no fractions here. So I need to multiply this by what? In order to get rid of the fractions. Yeah, we got to multiply everything in here by 2. Now this one we're already done. This is in standard form. Okay? But our standard form over here will end up being 0 is equal to negative. So we multiply by 2. The two 2's cancel out. So it just becomes negative x. We multiply this by 2 and this by 2. Negative x times negative 2y times negative 12. Now what I want you guys to realize is when we look at these, the coefficients in front of our y and our x are opposite of each other. Okay? Now this one's a little harder to see, and that's why it's usually best to go into slope y-intercept form. But if you notice, this is negative 1, this is a value of 2. So what you want to see is the coefficients being on different exponents. Sorry, not exponents, variables. So we have negative 1, negative 1. This was attached to the y, this was attached to the x. Here we have negative 2 and positive 2. So they're opposite of each other. Now, it can be really hard in standard form to see, so if you can't, switch back to y-intercept form, which makes it a little easier to notice if they're perpendicular.